black holes, huh? They're like these massive mysteries in space that had scientists scratching their heads forever.
Yeah, like what's even inside one of those things?
I mean, we all know nothing, not even light, can escape a black hole's pull. So, like, how are we supposed to figure out what's going on in there?
It's definitely been a challenge, that's for sure. But there is some new research that's, well, it might be giving us a way to sort of peek behind the curtain of a black hole.
Ooh, okay, I like where this is going. That's exactly what we're diving into today, right?
Right.
We're looking at this article. It's from the Brighter Side of News, published January 30th, 2025. The title is Physicists Discover What's at the Core of a Black Hole.
Very catchy.
And basically, it's all about how scientists are now using, get this, quantum computing to try and solve, like, unlock the mysteries of black holes.
Yeah, and the really cool part is how they're going about it.
Okay.
It involves something called the holographic principle, which honestly could completely change how we understand the universe.
All right. Holographic principle. Got to admit, you got my attention, but I'm not sure I'm totally following.
Okay, so think of, like, watching a 3D movie,
Okay.
but on a flat screen, right? Like, the information's all still there, it's just presented in a different way.
Okay, yeah.
So the holographic principle, basically, it suggests that the universe could be kind of similar to that.
Whoa, wait a sec. Are you saying, like, our whole universe is, like, one giant hologram?
Yeah, it's a pretty wild idea, right?
Is it wild?
So, like, you've got gravity, which Einstein explained with his theory of general relativity.
Right.
And then you have particle physics. That's, you know, all about the tiny particles that make up everything. And that's explained by the Standard Model.
Okay.
But the thing is, these two, like, fundamental theories, they don't quite mesh.
Huh.
So, like, the Standard Model doesn't really include gravity, and that's a problem.
So it's like they're speaking different languages.
Exactly.
And we need to figure out how to translate between them.
Yeah, and the holographic principle is trying to do just that.
Okay, so how are these scientists using it to study black holes?
Well, they're using something called quantum matrix models to represent particle theory.
Quantum matrix models. I'm writing this down. Got to look it up later.
So the idea is, like, by studying these models, which are simpler to work with than, like, the whole universe, we might actually learn something about gravity.
All right, I'm starting to see the connection here.
Good.
But hold on, where does quantum computing fit into all of this? I mean, isn't that like a whole other level of complicated?
Yeah, but that's kind of the point.
Okay.
Quantum computers are, like, way more powerful than regular computers. They can actually do calculations that would be impossible for even, like, the most powerful supercomputer.
Wow.
And in this case, researchers, they use these things called quantum circuits, which are made up of qubits.
Oh, yeah, qubits. Those are the things that can be like a 0 and a 1 at the same time.
You got it. And by messing with these qubits, using certain operations or gates, they can create super complex algorithms. And those algorithms can actually solve the matrix model.
So it's kind of like a recipe, right?
Yeah.
You have your ingredients, the qubits and the instructions, the gates.
Precisely.
Combine them in just the right way, and boom, you get like this incredible outcome.
Yeah.
In this case, a solution that tells us something about black holes.
Exactly. So the researchers are basically using a quantum computer to try and figure out what's called the ground state of the matrix model.
Okay, ground state. I think I'm going to need a little help with that one.
Sure. So think of, like, a ball rolling around on a bumpy surface, you know? Eventually it's going to settle in the lowest point, right? Where it has the least energy.
Yeah, I guess.
So that's the ground state.
Yeah.
And it turns out particles in the matrix model, they have a ground state too. It's the lowest energy configuration they can be in.
So finding the ground state of this model is kind of like finding the most stable arrangement for those particles.
Exactly. And understanding that arrangement can give us all sorts of info about the system the model's representing, which in this case is a black hole.
Okay, this is where things start to get seriously interesting. I mean, they've got their quantum computer, they're manipulating those qubits, trying to find this ground state. But what does all that mean for, like, our understanding of black holes? Did they actually figure out what's at the core of one?
Well, it's not exactly as simple as taking, like, a picture of the inside of a black hole.
Right.
But by figuring out the ground state of the matrix model, which is what they did, it gives us clues about, like, how the particles inside a black hole are arranged and what their properties are.
Okay, so it's not a direct look inside, but it's giving us some hints, right?
Right. And this is where that holographic principle comes back in, remember? That connection between particle physics and gravity.
Uh-huh.
Well, because of that link, the arrangement of those particles in the ground state, it can actually tell us something about the gravity inside the black hole.
Oh, wow. So the ground state isn't just about the particles themselves. It's like a window into how gravity works in there.
Exactly. And that's a huge deal because one of the biggest mysteries in physics is how to combine gravity with all the other forces in the universe.
Right.
And this research, it's bringing us one step closer to doing that.
I got to say, this is seriously mind-blowing stuff.
Mm.
But before we, totally lose ourselves in the depths of black holes, maybe we should take a quick breather.
Yeah, good idea.
Don't forget, folks, you got to like and subscribe to Deep Dive for more amazing journeys into the world of science.
And if you've got any ideas for what we should explore next, leave us a comment below.
We're always looking for new mysteries to unpack.
Okay, so back to those groundbreaking findings. The researchers, they decided to use two specific matrix models. And these models, they're pretty simple,
Okay.
but they've got some key features that are similar to way more complex models. And those complex models are used to describe black holes through something called holographic duality.
Whoa. Hold up a sec. Holographic duality. You got to break that one down for me.
All right. Remember how we were talking about the holographic principle before?
Yeah.
So it says that gravity and particle physics are really just different ways of looking at the same thing, right?
Uh-huh.
Well, holographic duality, it's a bit more specific. It suggests that there's a direct mathematical connection between a theory of gravity in one kind of space-time
Okay.
and a theory of quantum fields, but without gravity in a different space-time.
So, it's a translation guide between gravity and particle physics.
Yeah, that's a great way to put it.
Awesome.
And this is where those simpler matrix models come in.
Okay.
They might not be describing black holes directly,
Right.
but they've got this dual description in terms of a gravitational theory that does involve black holes.
Okay. So, by studying those simpler models and using this holographic duality idea, scientists can learn something about those more complex gravitational systems. Okay, I think I'm starting to wrap my head around this.
Good.
So let me see if I've got this straight.
Go ahead.
We've got these researchers using these simplified matrix models to study black holes, and they're using quantum computers to find the ground state of those models, which can tell us how particles are arranged inside a black hole, and even something about how gravity works in there.
Exactly. You've got it.
Awesome. This is seriously impressive stuff. But I'm still curious, what did they actually discover about the ground state of these matrix models? What does it tell us about what's going on inside a black hole?
Well, that's exactly what we're going to dig into next. So stay tuned as we continue our deep dive into the fascinating world of black holes and quantum computing.
You don't want to miss it.
All right, so the researchers, what they found, it really gives us some fascinating insights into, what's happening inside a black hole.
Okay, so they found the ground state,
Yeah.
right? But what does that arrangement even look like? And what does it tell us about the, inside of a black hole?
Okay, so imagine a perfectly smooth sphere.
Okay.
That's basically the ground state they found.
Huh?
It means the particles are arranged in a very symmetrical way.
So no, crazy swirling vortex or anything.
Yeah.
Just a perfectly calm sphere.
In this model, yeah. But of course, real black holes are way more complicated.
Right. Yeah.
But this gives us a basic understanding of how those particles act in such extreme gravity.
I see. So even though we can't, actually see inside a black hole,
Yeah.
this research gives us a theoretical peek into its structure.
Exactly. And here's where that holographic principle comes back in. Remember that duality we talked about?
Yeah.
The connection between particle physics and gravity.
Right.
Well, that connection means the arrangement of the particles in the ground state can tell us something about the gravity inside the black hole, too.
Whoa. Okay. So the ground state isn't just about the particles. It's also a way to understand gravity itself.
Exactly. And that's a huge deal, because one of the biggest challenges in physics is figuring out how to bring gravity together with all the other fundamental forces.
Right.
And this research, by connecting the ground state of that matrix model to the black hole's gravity, it's getting us closer to doing just that.
So this is about way more than just black holes, right?
Right.
It's about understanding the fundamental laws of the universe.
You got it. And the fact that they managed to do this using quantum computing, it just opens up so many possibilities. It shows how powerful this technology could be for tackling the biggest questions in physics.
It feels like we're on the verge of like a whole new era of scientific discovery.
For sure.
But I'm guessing there were still like challenges ahead, right?
Yeah, definitely. Right now, quantum computers, they're limited by how many qubits they can handle,
Uh-huh.
and by this thing called noise, which basically throws errors into the calculations.
So it's like trying to, I don't know, listen to a radio station with a bunch of static.
Yeah, that's a good analogy.
Okay.
But as the technology gets better
Hmm.
and researchers figure out even more sophisticated algorithms, we
Yeah.
can expect like even more groundbreaking discoveries about the universe.
Okay, this is seriously mind-boggling stuff.
Yeah.
I mean, we've gone from the holographic principle to quantum computing to matrix models and now the ground state.
Hmm.
But I'm curious, what's next for this research?
Right.
Like, what are the researchers planning to do now?
Well, first off, they want to test their algorithms on like bigger and more complex matrix models.
Right.
And they're also trying to figure out how to deal with that noise we talked about to
Right.
make their quantum calculations more accurate.
Right.
And ultimately, the goal is to use these techniques to study even more complex systems, like
Mhm.
maybe the early universe or
Ah.
even like the Big Bang itself.
That's seriously ambitious.
Yeah.
Wow. Okay, before we get too lost in, like, the vastness of space and time, maybe we can bring things back down to earth a bit.
Yeah.
Can you tell us about any, like, real-world applications for this research?
Yeah, that's a good question. So, this research is mainly focused on like fundamental physics,
Mm-hmm.
but it could actually have some pretty big impacts on other fields too.
Really? Like what?
Well, for example, understanding how particles behave in super strong gravity could lead to new discoveries in material science.
Mm-hmm.
Like we might be able to create new materials with, properties we never thought possible. And figuring out more powerful quantum algorithms that could have applications in all sorts of fields like drug discovery or
Uh-huh.
even financial modeling.
Wow. So the impact of this research goes way beyond just theoretical physics, huh?
For sure, it just shows how powerful scientific curiosity can be and
Yeah.
how unexpected discoveries can change the world.
Absolutely.
Mhm.
It's pretty amazing to think about, right? Studying something as like abstract as the ground state of a matrix model could actually have real-world effects.
Yeah, it really shows how, like, all of science is connected, A breakthrough in one area can totally shake things up in a bunch of other fields.
This has been an incredible deep dive for sure into the world of black holes and quantum computing.
What really stood out to you?
I gotta say, for me, it's just like the sheer scale of it all.
Yeah.
Scientists using quantum computers to study objects like billions of times bigger than our sun. That's just wild.
It really is. And the crazy thing is, we're only just starting to figure out what's possible with this technology.
Right. Like, who knows what other secrets of the universe we'll be able to uncover as quantum computing gets even more powerful.
It's a pretty exciting time to be, like, following all this stuff.
Totally agree. All right, before we wrap things up, got to remind everyone to like and subscribe to Deep Dive for more deep dives into the world of science and technology.
And if you've got any ideas for future deep dives, drop them in the comments below.
We're always on the lookout for new topics to, well, dive into.
This whole deep dive into black holes and quantum computing, it's got me thinking.
Oh, yeah.
About what?
Well, if we can actually use quantum computers to, like, simulate and study the universe, what does that even mean for reality itself?
Whoa. Okay, getting deep now.
Like, is it possible, just maybe, that our universe is a simulation
Or-
running on some, like, crazy advanced quantum computer out there?
Now that's something to think about, huh?
Definitely something to ponder.
Until next time, keep those brains buzzing.